Powers. The term 2 cubed is a power term. Two is defined as the base, while 3 is defined as the exponent. The exponent indicates how many times the base is multiplied by itself. Let me repeat this because this is important. The exponent indicates how many times the base is multiplied by itself. In the term 2 cubed, 2 is multiplied by itself 3 times. This means 2 cubed equals 2 times 2 times 2. Square powers. When we square a power, we would be finding the square of a number, which is the number multiplied by itself. To cube a power, we would multiply the number by itself 3 times. To find a power in general, we just multiply the number by itself as many times as the power. So to square, multiply the number by itself. To cube, multiply the number by itself 3 times. And to find a power in general, multiply the number by itself as many times as the power. So finding the square of 2 is just 2 times itself, which is 4. To find the square of 39 would be 39 times itself, which equals 1,521. To find the square of 100, multiply 100 by itself, and you'll get 10,000. Finding the cube of 2 would be 2 times itself 3 times, which equals 8. The cube of 39 is 39 times itself 3 times, which is 59,319. And the cube of 100 is 100 times itself 3 times, which is 1,000,000. If we wanted to find 2 to a different power, say to the 5th power, then we would multiply 2 how many times? That's right, 5 times, as many times as the number of the exponent. So 2 times itself 5 times is 32. What if we want to find 10 to the 6th power? How many times will we multiply it? The number of the exponent, which is 6. So we multiply 10 by itself 6 times to find 10 to the 6th power, which 10 by itself 6 times is 1,000,000. And this is powers. Roots. The term cube root of 2 is called a root term. In such a root term, 2 is the base, while 3 is the root exponent. The base is the number left when the root term is multiplied by itself as many times as the number of the root exponent. So in the term cube root of 2, 2 is the number left when the root term is multiplied by itself 3 times the number of the root exponent. So cube root of 2 multiplied by itself 3 times equals 2. The number inside of the root symbol. Powers versus roots. Roots are difficult to understand, but something that can help is if we can remember that roots are basically the opposite operation of a power. So let's put this in easy terms that might help us understand how they are opposites. Looking at addition and subtraction, we know these are opposite operations. Because if we have 2 apples and we add 2 more apples, we get 4 apples. Then if we subtract 2 apples from that 4, we're back at 2 apples again. And this is because addition and subtraction are opposite operations. Similarly, if we have 2 apples, we raise them to the 2nd power, which is squaring, which remember that's multiplying the base by itself. So 2 apples times 2 apples is 4 apples. Then we can Then take the square root of those 4 apples, and we'll be back to what we started with, 2 apples. Why is this true? Well, because roots apply the opposite operations to the power. So if we find the square of a number, then find the square root, we'll be back at the number we started with. So square roots, well, as we saw, a root is what we get when we reverse a power expression. It's the opposite operation. So 2 squared would be 2 times itself, which is 4, and the square root of 4 then will take us back to 2. It basically undoes the power operation. Therefore, the square root of 2 squared is 2. So it's like the 2, the square, and the root cancel each other out, in a sense. Because roots and powers are opposite operations. So finding the square root of a squared number leaves the original number. So here are the steps for finding square roots with the information that we have seen so far. We would want to change the base of our root term to a perfect square. Then use the square to cancel the square root. So let's look at some examples. If we want to find the square root of 4, we'll just change the 4 to a perfect square, which 4 equals 2 squared. Then the root and the power cancel each other out, leaving 2 as the square root of 4. Let's look at a larger number. Square root of 1,521. We'll change it to a perfect square, as step 1 says. Well, 1,521 equals 39 squared. And now we have a square and a square root, so those operations undo each other, and we're left with what's inside the root, 39. So the square root of 1,521 is 39. Now let's look at the square root of an even bigger number, 10,000. Well, same thing, step 1, change it to a perfect square. Well, 100 squared equals 10,000. So if we change it to the square root of 100 squared, our power and our root will undo each other, and we're left with the base of our power, which is 100. So the square root of 10,000 equals 100. Let's take the root concept to the next level. Suppose we want to find the cube root of a number. Well, remember, a root is what we get when we reverse a power expression. When we use roots to undo power expression. So 2 cubed equals 8, as we've seen. And now the cube root of 8 would be 2. If we do the opposite operation on our result, we get back to our original number, 2. So cube root is the opposite operation to cubing. Therefore, the cube root of 2 cubed equals 2, because the cube and the cube root undo each other. Because roots and powers are opposite operations, finding the cube root of a cube number leaves the original number. The cube root of 2 cubed is 2. So here are the steps for finding cube roots. Step 1, we want to change the base to a perfect cube. So before, when we were finding the square root, we changed the base to, what was it? The perfect square. This time we're looking at cube roots, so now we're changing the base to the perfect cube. Step 2 then is to just use the cube to cancel the cube root. So let's look at some examples applying these steps. We already know that the cube root of 8, as we saw, equals the cube root of 2 cubed. We change 8 to a perfect cube. 8 equals 2 cubed. So now our cube root and our cube cancel each other out, and we're left with our base number, which is 2. So the cube root of 8 equals 2. What if we look at a larger number? Say we want to find the cube root of 59,319. Well, 59,319 equals the perfect cube, 39 cubed. And the cube root of 39 cubed then is just that base number, 39, because the cube and cube root undo each other. Let's look at an even bigger number. Say we want to find the cube root of 1 million. What do? What was our first step? Change that base to a perfect cube. 1 million equals 100 cubed. So if we just change our problem to the cube root of 100 cubed, our cube and our cube root cancel each other out, and we're left with that base of 100. So the cube root of 1 million equals 100. We've seen how to find the square root of a number and the cube root of a number. What if we want to find the root of a number in general? Well, let's take it to the next level. The steps for finding the square root was, the first step for both the square root and the cube root was to change the base to a perfect square or perfect cube. We can apply the same concept to a root in general. We just need to change that base to a perfect power that matches that root exponent. So change the base to a perfect power would be the first step. And then the second step, what do you think it is? You guessed it. The power then will cancel the root as long as the root exponent and the exponent are the same number. So let's apply these steps to some examples. So if we want to find the fifth root of 32, the important thing to notice is that our root exponent is 5. So we need a power expression with a power of 5 that's equal to 32. Well, 2 to the 5th power equals 32. So if we change this to the 5th root of 2 to the 5th, our 5's cancel and we're left with the base, which is 2. So 32 to the 5th power, 32 to the 5th root is 2. Looking at a larger number, if we want to find the 6th root of 1 million, well, our root exponent is 6, so we need a power expression with an exponent of 6 that's equal to 1 million. Well, 1 million just happens to equal 10 to the 6th power. So if we change this to the 6th root of 10 to the 6th, our 6th power and our 6th root will undo each other, and we're left with the base, which is 10. So 1 million, that is the 6th root of 1 million, equals 10. What if we want to find a root that does not have a corresponding perfect power? Well, that is, the base of the root does not have a perfect power, so the root of the number does not equal a whole number. And we will need to use a calculator to find the root. For example, if we were to find the square root of 7, what we would actually get is something that's not a whole number. It contains a decimal. Square root of 7 equals 2.65. The way we would find this is just to plug that square root of 7 into the calculator, and it will give us back 2.65. For more detailed instructions, see your calculator manual or the instructions provided online.